Oh, hello everyone. Welcome to another Teach Kelvin Your Thing session. And in this session, we have Brett Sutton with us, who is going to be teaching us a bit about building that CLI app. So, Brett, can we meet you?
How are you? Uh, so you want to know a bit about me, I gather? I guess I've been doing development for a long time. I've programmed in quite a few languages, mostly C++, I think C, Java, I guess the last couple of years Dart. So I've been building and enjoying the Dart experience, building a lot of back-end Dart applications. I guess a core bit of what we started was I have a company and we wanted to rebuild our DevOps environment in terms of doing deployments. And we really started out wanting to, I guess, go through and remove a whole lot of different languages we had in our DevOps environment. We had Ruby, PHP, Go, Bash scripts. And so we wanted to really just refine that down to using a single language. And those DCli was really born out of that effort to actually create, replace our entire DevOps systems with a single platform, a single language. And so we spent the last 2 years doing that, which we've now completed, and the team loves what we've done. So we now have a single language rather than a fragmented development environment.
Okay, awesome. So, a little bit of just one side question, like, what do you really think about the Dart language? So, you've using it for so long.
Look, I've often been quoted as saying Dart is delightful. It's a really nice language. I think when I look at languages, I look at there's a whole lot of metrics I tend to look at that make me like or dislike language. And one of the things often is like the terseness versus the verbosity of the language. And I think Dart hits a really nice medium in terms of not being too terse and not being too verbose. Java has a habit of being fairly verbose. You get to languages like Perl and they're really terse. Both are bad. Terse languages, you can type very little small amounts of code and get something really powerful, but you come back 2 years later and look at the code and go, I've got no idea what that code does anymore. It's just too terse and too hard to parse.
Mm-hmm.
Languages like the Java, you tend to have a lot of boilerplate, so there's a lot of extra code that you need to write to actually get something up and running. Dart, I think, balances those two things very nicely. So I just really quite like a lot of the solutions that the Google developers did in creating Dart that actually makes it very fluid to actually build applications with. There are a few bits I don't like. I don't love futures. I think futures came about because of the JavaScript compatibility issue and promises, but I'm really not in love with it. It tends to be a bit of a virus in your programming that you start using a future, it tends to cascade through your whole application.
Mm-hmm.
So that's probably one of the biggest issues I have with Dart. It's manageable. I do miss things like the way Go uses code reading and stuff like that. How easy it actually to launch a threading in the likes of Go. Isolates, I think, in Dart have some problems in terms of performance. The amount of effort required to actually start up an isolate and move data across it is problematic. We were having problems at one point with a Flutter app wanting to deserialize large quantities of JSON. And we thought, let's just move it across to an isolate, deserialize it there. The problem is we're still getting jank because just moving the data through to the isolate was so expensive in terms of CPU. The isolates really didn't actually help us solve the problem in that case. So I think there's some work to be done by Google in terms of how it works with isolates as well. So that's probably my only complaint. And I guess the final one is just maturity at this point. The package ecosystem is still somewhat weak. It is, I think in the last 12 months, it went from something like 10 to 20,000 packages on PubDev, so it's growing massively. But we still don't quite have the scale of mature packages out there that we need to solve all the problems. You look at the Java environment, and if I need to do something, it's a package there, it's mature, I just grab it and go. There's certainly more work in the Dart community done around that.
Oh, awesome. Gotcha. Okay, so let's get on with the Darts for CLI applications. So it's all yours from now on.
All right, so let me show my screen and let's go to bring up a client. So I'm going to take you through, so I should explain there's two parts to DCli if you like. There is the command line tooling that DCli provides, and there's the DCli library itself. You don't need to use the command line tooling, it's just a convenience. You can just use the CLI libraries inside your application. So let's start off by installing, once I get my screen to share properly.
Okay.
1 second. Okay, so let's bring up a command line. So I'm using Windows at the moment. Most of the development I actually do is in Linux, but I don't have a camera in my Linux box. So here we are doing Windows. So let's start by installing DCli, which is pretty easy. So DCli contains a number of binaries, which is why it takes a little while. It's got to go pre-execute, pre-compile them. So it contains the main DCli application. It includes an installer. And if you're on Linux, it also has a autocomplete script. So we've essentially just installed the DCli package. Let's just now finish the install process by using DCli install, which has been done. So DCli, as we'll see in a minute, has the ability to actually add CLI scripts you've built into your path, which can be really handy. And we'll look at that as we go through the process. So now let's just create a new directory. What do we call this directory? Is it TKY? And let's create our first script. What do we call this? We're going to call it Git GC .dart. For development environments, I use Visual Code. I've done some Android Studio development with Dart, and I hate Android Studio. It is a terrible idea, in my opinion.
Me too.
Yeah, so VS Code, it's, I've used a lot of time spent using Eclipse, and it's probably not as powerful as the likes of Eclipse, but it's fast, it's easy to use, it lets you do remote development, which is a really handy little feature. So there's a lot to be going for it. The Dart developer, I've forgotten blank on his name now, who manages VS Code package for Dart, is also really helpful if you've got problems with it as well. So, all right, so let's just start. I'm just going to gut this for a second. So basically, when you create your first DCli script using the create command, it creates a little template for you, which I've just deleted the gut, so I'll just talk about what it does. So if you're writing a CLI application, like Java, like C, DCli has a main method with the signature, as you can see here, void main, a list of strings. You don't have to pass the list of strings, but you normally need to do it. So the list of strings basically gives you the arguments you pass on the command line. So let's do some really basic stuff here. Let's do the classic hello world. So now if I bring up a command prompt next to that, my command prompt, it just disappear on me. Let me just open a new command prompt because I don't use Windows every day and it's been difficult for a minute.
Yeah, Windows. Windows.
So let's try that again.
Okay.
Come on.
Okay.
Okay, we're here. All right, so you can now see we actually have Git GC.dart. Let's just run that and prove that it actually works. So we can literally go dart Git GC.dart. Now, if you're on Linux, you can actually just type /Git GC.dart. You don't need to put the Dart in front of it. There is some work being done on Windows to make that work as well, but Windows is a little more difficult. So you can see we've got a very simple hello world application. So let's look at one of the first things I like about DCli is its ability to color code things. So if we want to color code that, we simply go red, wrap that as it's a function call, we wrap the hello world in it. If we run our script up again, we'll see now we've actually got a color coded piece of text. So there's a range of standard functions, color functions that DCli ships with, red, green, orange, yellow, blue, that just make it nice and easy to actually color code your world as you go. I find that quite important when I'm writing CLI scripts, because color coding can really actually make it easier for your user to see what's going on. So let's do the next most common thing. We want to get some input from the user. Let's ask a user for something. Let's ask them for the name. So let's go ask, and we're going to basically pass in what is your name. I can type, and we're going to put that in a variable. So now we're in a script. Now we should be, you'll notice that we've got some linting. So when you create your DCli script for the first time, I add in analysis options by default, and I turn on strict mode. I really recommend you stick with the strict mode, and it'll actually make your coding life much easier. So we can see now I've run it up, hello world, what is your name? If I type in Brett, we now have Brett in a variable. So ask also has a few nice features. You can set a default value. If someone doesn't enter it, you can also set validators. So a validator might be something like ask dot, and you'll see we've got a whole chunk of validators that ship with DCli out of the box. So we might do something like, I don't know, FQDN. So now we might do something like host name. And so I won't go through that process, but you'll then ask you for a valid FQDN. It won't let you actually leave the input box, the input, until you've actually entered the valid, fully qualified domain name.
Wow. Nice.
So the next little one is confirm. So if confirm, continue is probably a classic one. So in fact, let's do something like this. If not continue, then we're going to exit. So CLI applications have exit codes. If you've ever done Bash, you can actually test the output of an exit program. By convention, CLI applications that complete successfully should exit with 0. If you don't have an exit statement, your program, when it exits, will exit with 0 by default. But if you want to indicate an error or some sort of problem, you should return typically a positive number as an exit code. So in this case, we run up our script again. It should ask us for a host name. So we won't continue, and if we, well, both cases we're going to exit, but if I hit no, it would have gone through the exit path. So we've now got some, basic building blocks for user interaction. There's also a menu option, which I'm not going to go through now, but you can actually create a little menu of options and let the user choose from, 1 to n options from a menu. I use that. I've got another tool called Pub Release, which automates the process of releasing packages to pub.dev. And so one of the things it does, it pops up a little menu saying, well, using semantic versioning, is this a breaking change, a minor change, and it'll then choose the correct version number based on the sort of semantic change that your code's gone through. And I use a menu from DCli to do that. Let's have a look at which. So sometimes when you talk something about how you run other applications from DCli. So one of the things we often do is we want to know where the application's installed. So DCli's got the which command built into it. And we simply just pass in a name. So ls might be an example. Does the ls command exist? Just a word of warning, there are some commands which are built into the likes of the bash shell, like the echo command. You're not going to find it on the path, which won't return anything, because it's not actually a separate application. It's built into the shell. So even with Windows, you need to be aware of that. There are some commands which are built into the shell which you can't find. But the which command will do things. We can do things like the which if ls dot found or not found are two of the options it returns, or the actual path. So you can do things, if not found, well, we need to do something different. And in fact, you wouldn't normally run the ls command. We have in DCli a find command, which we use for, just 1 second, before I just get access to something. The find command we use to actually finding things on disk. So we might go something like this, find star.text. So this now, we go to list. So instead of using the ls command, we can use the find command, which will give us a list of text files. So the find command will go and search the current directory for all .text files and return them. Now let me stand back for a second and talk about actual directories, because I'm not going to spend a whole lot of time on this, but if you've ever done like bash command programming or used a shell, the cd command features fairly strongly. When you're writing a client application using the likes of cd, pushd, popd, from familiar with those, which lets you push a directory and change at the same time, then pop back to where you were, they're essentially evil. You changing directories inside a client application is quite dangerous, because you can change a directory and then forget in a function that you've called, and then when it comes back, you forget to change back, and suddenly you're doing an operation in a directory you don't expect to be doing the operation. So when you're running console applications, I strongly recommend you don't use tools like cd, push and pop to change directories. There's also problems when you're using isolates, because a process, whether it's Windows or Linux, only has one current working directory. So if you've got two isolates running, they're both changing directories, well, one changes the directory, but the other isolate's also going to get the same directory change without realizing it. And so you can have real problems where you end up deleting files, for instance, that you didn't expect to delete. So the DCli principle is that you'll find lots of commands take a working directory as an argument. So the find command takes working directory, and I'm going to use another variable that DCli exposes called home. So the home is a global variable that has my the specific home directory. So on Linux, it'll be /home/b Sutton. On Windows, it's used as Brett or whatever. So the home is a convenience variable, and working directory will tell the find command is going to search for .text files in the working directory, which is home in this case. You can also get the current working directory. pwd is another global variable that gives you the current working directory. But again, you tend to use that occasionally when you're starting programs up and you want to run from where the current the user ran the command from. But there are better ways of doing that typically.
Thanks.
So we probably should talk about path creation. I think is a really key piece of how, when you're doing DCli type scripts. The DCli package includes the path package from Google. And the path package is about creating directory structures, directory paths, surprisingly not. So for instance, if we want to do, let's say we want to go create a directory where we're going to store some stuff. So we want to go, what do we call this? I'm going to call it pub. I can't think of any other terms. That's just what comes to mind. I'm going to use the join command from the path package, home, comma, pub. So what that's going to do is create a path, which is, in this case, user Brett pub. So I can now do something like, let's go and create a directory at the pub path. So now what we've done is we've actually created the directory user Brett pub. Now, if we can go further than this, call it base. So now the correct directory is actually going to fail in this case, because by default it doesn't do recursive create. It's happy to create the pub directory, but it only has to create one directory. But pub and base requires us to create two directories. So to do that, it's called a recursive. And this is similar to how bash works as well. There's actually a recursive option true. It's now happy to create those two directories. DCli very much uses a process whereby you have to be explicit. One of the big problems of the likes of bash, if you've used that, is that it's very easy to run a command and not test whether it returns an error. So an example, you can do cd in bash, and the cd fails because the directory name you passed is invalid. And then you go do a delete thinking you're in the right directory and you're not actually in there. So DCli takes a different approach in that if you try and do something and it fails, it's going to throw an exception. Virtually all the exceptions that DCli throw are based off a base class called DCli exception. The exception to that is that there are some system level exceptions that get thrown occasionally, but mostly we try to avoid that. So you've got an existent, a simple catch mechanism. Am I making sense so far?
Yeah, sure. Perfect sense. I'm liking DCli.
So do I. So we can So, okay, so we can create directories fairly simply. Let's now, so you can see the path command. The join command is the most obvious one. There's some other nice ones as well. For instance, there is the base name. So if we go var file name equals, if we create a path, something like join home thread.text, well, base name is going to, and we can now call another path function called base name. So if we wrap that in base name, that's going to return thread.text. It's going to drop off the home and return thread.text. So that could be quite useful functionality. I strongly recommend if you're going to do much work, you should go read up on the paths package on pub.dev. It explains a lot of the functions it uses. I will go through one more. It's also commonly used. If we go directory equals dir name pub. So earlier we created the pub variable up here. And so basically what we're saying is now just return the dir name. Well, the dir name of that's going to be user Brett pub. So it strips off the last chunk basically and gives you the dir name. In the case of if we passed home thread.text, it would just return the home directory in this case. So it's another useful tool that I use all the time. But hey, let's actually do something useful now. Let's actually get rid of all this for a moment. So I imagine lots of people watching this use Git. I use Git. I have probably 50 or 60 Git projects in my home directory. What a lot of people don't know is that Git supports the concept of garbage collection. When you do lots of commits and pushes, etc., it actually has objects that needs to be freed up. And so it's useful to occasionally run the Git GC command, which goes and deletes a lot of unused objects in your Git folder. Which can actually speed up Git's operation. So let's actually go do something practical. Let's write a little script that actually goes and runs Git GC for us across our home directory. So we talked about the find command. We want to actually find all the directories that have a Git enabled in them. And the way we can do that is looking for the .git directory. So if we go find .git. Now, we don't need to put a working directory because we're normally going to run this from our home directory, so that'll be fine. What we do need to do though is we need to include hidden files. So by default, the find command will ignore any files that begin with a dot. This is more of a Linux convention than a Windows one, but it's a little bit the same with Windows. So by default, find will ignore those, so we need to turn the include hidden flag on, so find will actually find the .git files. We are also looking for a directory. So normally the find command finds files, but we can tell it that we want to find directories by specifying types. So find.directory, and we can now say we're finding directories as opposed to files. So once we do that, we're going to use the for each command. So the find returns what's called a progress, and the progress has a for each operation on it. And so basically for each Git directory it finds, it's going to return, we're going to call it Git path. This is a lambda we're building up here. So what we want to do here is, let's do something simple. Let's print out, let's use blue this time, shall we? I like blue. Cleaning $Git path. So a semicolon where we need it. Let's just run that up for a second. So I want to do it from here, tky slash, what I call this? I actually called it Git GC, didn't I?
Yes, you did. Dot.
So let's see if I can actually get this correct. And I screwed something up.
Oh, denied.
Access denied.
Yeah, permissions.
Yes, permissions. So I thought I was an administrator already. I'm surprised. I'm not a Windows expert, and I probably should have done this on Windows. How can we avoid that problem? I'm not certain how to solve the problem for a second.
Yeah.
What I will do, we'll just set this up so we just find one of these things, working directory, where are we? I think I've got DCli sitting here on my working directory. So let's just start it from DCli. So you can see now what I've done here is I've instantly said, okay, well, I'm not going to use my home directory, the current users directory. I'm going to use the DCli directory, which is relative to where the user's starting the script, which is a little dangerous, but we'll do it for a second.
Okay.
Okay, that's better. So we actually found the .git file in the DCli directory and avoided the out permissions problem. So the reason I said using DCli is a little bit dangerous is it's a relative path. You need to be a little bit careful using a relative path. I prefer to use absolute paths all the time, and because it is safer in terms of one of the key elements of absolute versus relative paths is particularly with error messages to users. One of my big gripes about CLI applications is often they'll give you a relative path. Well, that's fine if you're running that application from the console directly. But if you're running the application from another application, another CLI script, which is very common, you don't know what directory it was being run from when that second application was being run. So relative paths often are very misleading and very unhelpful for error messages. So particularly when I'm outputting paths for error messages, I tend to use an absolute path. And in fact, DCli has a method called true path, which does a little more with an absolute path, also canonicalizes the path as well, which I'm not going to go into right now, but I recommend you use the likes of true path to generate your paths. So true path is really a super version of the join command we saw earlier, which creates an absolute path. So now, instead of using DCli, we're going to use path here. All right, so now we've got the files. Let's actually do the next interesting thing. This is where the power of DCli comes in, running applications. So now we've got the path, we're actually going to run Git GC, and we need to now control what directory we're going to run this in. So DCli has a simple run command. I can go run, that will run the Git command in the current working directory. And so the run command is one of the simplest methods of running an application, another CLI application. So when you build CLI applications, you spend a lot of time building simple little CLI applications that call each other. But one of the core principles of Linux has always been about building little reusable components and then linking together to create bigger, useful things. DCli encourages that same process where it's designed to make it very easy to run other applications. So the run command will simply run Git GC and output its whatever Git output. So let's just run that and just see what we get.
All right.
I haven't run Git GC for a long time. Now what have I done? DCli does not exist. So home. I forget, on Windows, home doesn't quite mean what you think it does. Home is actually returns the roaming directory. So let's actually, I always forget that one. So let's do this properly. So root path on Windows is going to be like C:/. On Linux, it'll be just slash. So root path is a good way to create an absolute path. So we want C:/. It's then users. Windows is case insensitive, of course. So that should work for us. Let's try that again with the correct path now. Okay, so what did we do wrong? Not a Git repository. So we've actually, you can see here that the key thing is we've actually tried to run the Git command. But, okay, what it's complaining about, not a Git repository, we've run the Git command actually in the user Brett directory because we haven't, the run command is going to run where in your current working directory. Well, at this point, in the code, the current working directory is user Brett. So we need to switch to using the start command. So like the run command, the start command runs an executable, but it allows us to pass some extra directories. And this time we want this to have the, get out of my way, tooltips. We want to pass in a Git path. So now when we run the command, it'll actually run the Git GC from the correct directory, which is the DCli directory. And in fact, looks like Git GC doesn't actually output anything. So we actually managed to run that. Let's just prove I'm not lying there. I may actually be lying. Let's just see Git GC. Right, so I was lying. So the start command, I've just forgotten how this works. By default, doesn't output, it suppresses any output. But we can actually get the output back in using what's called a progress. So the start command takes a progress, and if we go progress, and there's a number of standard progresses, we just want the print one, which basically says print everything that the command outputs. So sorry, that's what Git GC does. If we run our command again from the right directory, we should now get the output from the underlying GC command. And I'm doing something wrong and I can't think what at the moment, so I'm not even going to try and fix that. Okay. But yes, I'll come back to that one.
Okay.
So yes, you can control how the command outputs things. There's a slight chance it's printing a standard error. So perhaps I'll actually talk briefly about standard error versus standard out. When you're building CLI applications, people talk about a CLI application having access to 3 files: standard in, standard out, standard error. Standard in is when you type at the keyboard, it's sent via essentially a pipe into your command, and you can read that from a file descriptor called standard in, which Dart exposes. You also have standard out and standard error. So when you run an application like Git GC, most of its output will be sent to standard out. However, if it has an error condition, it will output to standard error. And so they're two different streams. You need to actually treat and actually capture them differently at times. So in our own program, we can actually do that by using print. So print will actually output to standard out, whereas if you go print error, that's actually going to get printed out to standard error. And so there are conventions when you compile running CLI applications, in that when you have errors, you should choose print error to go to standard error. When you're doing normal output, you should use print to go to standard out. And so when using commands like start, you can actually handle standard out and standard error separately in terms of how you pipe them out of the command. It's a bit more advanced. I'm not going to go into details of that one at the moment. So let's briefly talk about environment variables. So one of the key things you often have to do when you're running command line apps is manage environment variables. Now, one of the mistakes that people often make is they think I can set an environment variable in my command and it's going to affect the shell that launched my command. It will not. Security restrictions stop you change the environment variable of the parent process that launched you. You can, however, influence the environment variables of any child applications you launch. So a classic scenario is that lots of commands, when you start them up, may require a password. And passing a password on the command line when you launch something like MySQL, for instance, is considered bad practice. Instead, a lot of those commands will let you pass an environment variable. So a classic example is we might do something like this. My password, and then we go and run something like, I don't remember this, the syntax for actually doing a MySQL passing the password as an environment variable. We'll pretend it's something like this. So basically, what happens now, when we actually run the MySQL command, it has access to a new environment variable called password, and providing MySQL accepts that, don't know that it does, it'll take the password out of that environment variable. You can also get an environment variable, so we can go print so basically now, if when you launch your application, there are environment variables, you can actually print them out. So, classic what we got in environment variables in Windows, classic environment variable is temp. So we can access that temp environment variable by going print temp. So we come with our code out for a second. We should be able to do that correctly. We should hopefully see the temp environment variable. There it is, use app data local temp. Nice. So you have very easy access in DCli to environment variables, which is fairly important to go forward. One of my favorite little tools is actually creating temporary files and directories. If you're running CLI scripts, you often need to create temporary directories and files, and there's a couple of nice little commands that let you do that. So with tempdir, we'll create a temporary directory, itemp. You can then do some operations. So you might want to do something like touch join itemp red.text, and we want to create that. So create, whoops, I can't remember. So now what we've done here, DCli will create a temporary directory in the system temp folder. It passes you the path. My temp dir is the path to that directory. It should be my temp path, would be a better variable name there. And then you can actually then do operations in that temporary directory. And once the function completes, DCli will actually delete that temporary directory for you. Now, sometimes when you're debugging your CLI applications, you want to actually keep the temporary directory, and there's actually a keep option, which is really for debugging purposes. It says don't delete the temporary directory after you finish with it. Normally, you don't want to use that, but occasionally, if you're trying diagnosing problems in your code, it's a really handy tool to do so. There's also the equivalent for a file with temp file, which is using the same syntax. I'll let you create a temporary file. It will again be deleted after you finish the operation. I particularly find those helpful when I'm running unit tests. Generally, when you're running unit tests for your CLI applications, you're creating lots of directories and lots of files. I tend to create a temporary directory and redirect the tool I'm using to actually operate within those temporary directories, so it doesn't mess up my normal directory structure. So it runs those tests. Do you have any questions out of that?
Nope. I'm following through. Gotcha. So let's talk about moving files around the system. So DCli has a number of standard commands. Copy, which will copy a file. Copy tree copies a whole directory tree. You've got an option to do some filtering in there. One thing we do try with DCli is to actually write useful help. For most of the functions you've got there, there'll be actual sample code that shows you how to use it. So do look at the help as you go, because it is fairly helpful. There's a copy command, there's a move command. Now the move command can move a file or a whole directory tree or directories. And it tries to be reasonably intelligent in that it tries to be performant, i.e. it does a file system rename rather than actually moving the files. But of course, if you're moving across devices, rename doesn't work, so it will automatically fall back to doing our copy and delete if it can't use the OS's rename command. So it is quite efficient in that respect. So let's talk a little bit more about your environment as well. Sometimes you need to get access to the shell environment. So DCli has some commands, shell.current. Shell.current actually goes and tries to detect what shell you're using. Are you using command, are you using PowerShell, are you using bash, etc. And it then supports another number of operations you can do that it needs to know about your shell to do so. So one of the things we talk to is, one of the things we often have when you're writing command line scripts is to do with privileges. Mm-hmm. So privileges on Windows, that means you're running as administrator. On Linux and Mac OS, that means you're running as sudo. So there's some commands you need to run as sudo. Mm-hmm. Now, DCli has tooling that lets you know whether you're running as a privileged user. So the main tool you use here is privileged user. You can do that if your command needs to do privileged operations. I typically have a statement at the top of my command that checks whether I'm a privileged user or not. Is privileged user print? We said we should be using, because this is an error. You must run with privileges. Now, if you want to be a little more specific, that's a what the hell does that mean type question, we might do something like this. If platform, and this is a standard Dart variable, is Windows, you must run as administrator.
If it's not Windows, that means we're going to be on Linux or Mac OS. They both use sudo, so print error. As sudo. Now, let's talk about running with sudo. Because we've got here is Dart doesn't like running as sudo. There are all sorts of problems. When you run as sudo under Linux, as soon as you start touching files, you can change the ownership of those files to root, which means once you've stopped running sudo, you've actually kind of broken your file system because you've screwed up your permissions. So running as sudo is dangerous from that perspective. You need to be very careful about it. The other thing is that Dart also, when you want to Dart program, it may update your pub.dev, your pub cache. And so you can also change the ownership of pub cache. When you run sudo, your paths change. So typically a Dart script won't run under sudo because it can't actually find Dart to run it, or it can't find your pub cache because you're then running as root, and root has its own copy of pub cache. So there's a whole lot of problems around running a Dart script as sudo. So what you should do instead is you should compile the script. So one of the things that DCli lets you do is to actually compile your script. So Dart lets you do this, but DCli has a couple nice little options. So let's just do a compile first. Let's talk about what it means once we compile the script. So the advantage of compiling a script the way DCli does it is that it creates a single executable. That executable can then be copied to any other binary compatible system. So you can copy it to another Windows program, another Windows box. You can copy it to another Linux server if you compile it on Linux. And it doesn't require the Dart runtime. That means you've got a standalone executable you can copy anywhere and it will instantly run, which I find extremely useful, particularly in our production environment. We tend not to run Dart on our production servers. Instead, we just copy pre-compiled executables onto the other systems. Now, when I've compiled that, I still need to be in this current directory to actually execute that command. But DCli has a nice little option, which is -I, or let's do the full name, install. What DCli does when it compiles it now, it copies Git GC into a directory which is under use directory called .dcli bin. And as part of the install process, DCli will actually add DCli bin into your path. So now, I've not actually tried to test this on Windows before in this scenario. We should be able to now run DCli exe, so Git exe. So I managed to run that without specifying where it lived because it's now on my path. So the DCli install command I find really helpful because I now have a command I can access from anywhere.
Nice.
And if I want to run the likes of sudo, it's not important on Windows because you don't have those same issues with Windows. But under Linux and Mac OS, as soon as I compile it, I get around a whole lot of limitations that I have running as the Dart space script name. You get rid of most of the problems you have, and it's now then possible to run it as sudo, which is important in lots of circumstances when you're building CLI scripts. Is that making some sense?
Yes, it is. I'm learning a lot from using DCli, and I'm looking forward to trying it out on a little idea I have for an app, a CLI app actually.
So, what else we talk about then?
Okay.
So we're talking about, I know what we need to talk about, still argument parsing. So one of the big important things with building CLI scripts is parsing arguments.
Okay.
So we talked before about how we get, the main function gets a list of args. So let's just do a couple of things. Let's print args. Well, let's run. Now, don't make the mistake I have to do. I go to run the compiled executable. Of course, that's not going to have the latest changes in it. So let's just go back to our DKY directory. Let's run it the original way, gc.dart. And we should now see a empty array. So, but let's pass an argument to it. 1, 2, 3. So now we should see that we actually have 3 arguments in our array. Okay, great. So now we can actually pass in arguments and process them. So to make that easier, DCli includes the args package. Args package is another package which is released by Google, which is designed specifically for CLI applications and parsing command line arguments. So we do that by creating an arg parser. And if I can spell parser correctly, makes a lot of difference. So we've got an arg parser. We can now actually specify what sort of things we expect to get in. So add flag is probably the easy one. Add flag simply says something like we saw before with the DCli compile command had a minus install flag. So now we can go we can provide some help command, install the app. So what we also might need is, okay, we probably want a good idea to set a default value because it makes parsing this easier. Defaults to true. Okay. So now we've got a flag and we can go parser.parse, parsing the args in. So we've got the parsed args and we can now go parsed of, using the same name install, so we should be able to see now on our command line, we can actually pass in a flag. If we go -- install, do install. So now we can easily pass a flag in. You can also add options. We'll call it count, shall we? We have to declare that at first, of course. Add option. Let's give it a default as well. Defaults to 1. That does have to be a string apparently. Help. Number of installs. So now the option we should be able to print count. Now I've done this incorrectly because the option count is actually a string. I can't go just as in. That's going to fail because the parse was going to return a dynamic, which is under the hood is a string. So what I need to do is actually parse that. So autocomplete's not being very helpful. Int.parse. And generally try parse is the better option here. Okay. Because the parse option will throw an exception if it's not an int, whereas try parse will just return, it's been a while since I've used this, don't need it as int, will return a null rather. So what we can do here, once I remember the syntax of try parse, source parse, okay, so as string, because it will be a string, and what we can do here is go hook 0. So what that's saying here is try and parse the count as it's a string. If the parse fails, I haven't passed a numeric value, then we're going to return 0 because try parse returns null. So now if we go minus count equals 3, we've added an option to our command line. So again, there's a whole lot of other commands around that. I did something wrong. Oh no, 3. There we go. We got our 3 out of that. There's a whole lot of other commands, options on the parser. So again, I recommend you go look at the Google documentation on pub.dev for the args package. But it's quite flexible in terms of how you parse your command line arguments. And really, if you're going to build powerful command line commands, you really need to be able to parsing command line arguments. It's a core part of doing CLI development. So how are we going for time?
Yeah, we almost at the 1 hour benchmark, just 10 more minutes. But I think I like the DCli package. I think it's more geared towards real world use cases with the helpers and utilities it brings out of the box. I like it.
Yeah, DCli is really, I guess, the API has been developed from a fair amount of internal experience where we've tried to, if you like, create a Swiss Army knife of the common functions you are likely to use building CLI apps. We've got about 140,000 lines of DCli internally now that we use on and building that's really given the experience since we've fed back into the DCli package and what tooling we need around in the libraries to actually make it easy to use. So yes, it's really been from a chunk of experience we've had. So it's a fairly mature package. There's still a fair bit of evolution going on it. We're looking at introducing some async functions. Actually, that's a good point. Actually, one of the core things around DCli that we aim to do was to actually remove futures from it, because in 95% of cases when you're building CLI applications, you don't need to do things asynchronously. CLI applications tend to not really need to be particularly performant. Usually, you're doing things like installing a MySQL database. Well, the install process that MySQL goes through is going to take much longer than the time the CLI app runs. So generally, you don't get a much benefit from using asynchronous operations or even using isolates in CLI applications. There's certainly exceptions to that, and the DCli package doesn't stop you using those. You can still use futures when methods that return a future within DCli. You can still call isolates. It's just they're not very common. One of the things I do recommend is that if you're calling a function that gets called that returns a future, often you want to get rid of it. And so DCli has a function called wait for x. So wait for x, if you call some function, I can't think of one offhand that does it, file dot something. Yeah, that returns a future. So basically, file set last access is a method of setting the last access time on a file. What's date time dot now? Vaguely, that's how it works. But that returns a future. Well, you don't want to have to deal with the futures. You can actually wrap that in a wait for x, and wait for x actually removes the future from it. Wait for x only works in console applications. You can't use it in your Flutter application, and there's a whole lot of reasons why you shouldn't even consider doing that. But certainly for DCli, we use wait for x to actually eliminate futures just to make the programming model much simpler. It's very easy using futures to do things like, if you have to create a file and you have to copy it, well, if you forget to wait for the code to finish before you start copying, the copy is going to fail. So futures tend to cause more problems than good often in client programming. So we tend to try and eliminate them from the API we expose as part of DCli. But it doesn't stop you using them anyway.
Nice.
Um,
Okay. So I think I have a question. So do you use, like, are there CLI applications you've built with DCli that you use daily? Like, you just give me an example of some.
yeah. DSwitch is one of the CLI applications I use. So DSwitch is basically a tool that lets you switch between different versions of Dart. So the Google developers publish like a stable, a dev, and a beta release. And so DSwitch basically lets me switch between versions. So I can go DSwitch, I can type, use beta. So if I've got the beta version installed on my laptop, oh look, I've got a bug in DSwitch. So yes, like DSwitch I use every day, not in Windows, but it lets me switch between different versions of DCli. I've got pub release. I support quite a large number of packages. Pub release is written in DCli. It automates the process of releasing a package. Critical test is another package I use and have built with DCli. So critical test is about helping you run unit tests from the command line. There's pub release. So critical, if you ever use VS Code to run your unit test, you get a nice little window of failed and successful unit tests. You can rerun just the failed tests. Well, critical test does the same thing for your command line. What it does is it runs the unit test for your package. It suppresses output from tests that succeed and just shows you output from tests that failed. It then has the ability just to rerun failed tests rather than rerunning the whole unit test, as well as having techniques that let you run just individual unit tests that have failed. So it makes the whole running unit tests from the client much more iterative and easy to use. And so there's probably, I don't know, 10 different packages I've written in Dart that I use on a regular basis.
Oh, nice. So,
and of course, our DevOps environment, we've probably got, probably a couple hundred different DCli written scripts we use to deploy systems. We have an environment that runs MySQL, Java, in sort of your G Cloud environment, and we have scripts that actually build, from instantiating the VM to a completely finished deployed application, and that's all done with DCli.
awesome. So I'm really interested in hub release. So for work, I got those Dart ports of a socket client. I just ported it to Dart like yesterday. So I think I might be using the pub release. So is there any way you could just like show me how it works internally?
Yeah.
Sure.
Yep. So pub release is about pushing releases to pub.dev. Okay, so it automates the publishing process, and what it's doing, it's tagging your Git. So it goes into text that you run in Git. It'll create a tag in your Git repo. It'll commit. It'll update the version number of your package. It'll run the analysis package across it to make sure you don't have any errors on it. It will run the unit test of your package. So the aim of pub release is with one command, it gets your package all together, makes sure it's right. It pops open a editor to let you edit your release notes. So I particularly find, because I can sometimes do like 3 or 4 package releases in a day. Pub release just streamlines that process and makes it consistent. I'm always tagging my Git repo because pub release does it for me. I'm always running my unit test because it just does it automatically and I can't forget. And also it goes through and checks that my code's in a good state by running the analyst and also using the formatter across my code. So it's about providing a consistent release process that's quick and easy every time.
Awesome.
So the process of running, you simply go into your directory and run pub release, and using things like ask and confirm, it just takes the user through the process step by step.
Nice. All right. Thanks. Okay. I think this has been really insightful, and I'm definitely going to try out pub release. So thank you so much for this session on DCli. Thank you.
You're more than welcome.
Yeah, sure. Any words you want to share before we round up?
No, look, the way to get in products like DCli and Flutter is to find something you enjoy, you're interested in, and then using tools like DCli to do it. So, I start out with the likes of DCli. I've got little things that annoy me on a daily basis. They're good spots to start with DCli. Just little tools like the Git GC one that I use to actually run across all my directories on a regular basis. So building those little tools is a really good entry point into using likes of DCli. Don't try and do something huge initially. Just pick a few little housekeeping type tasks that will just make your life easier if you can automate them somewhat. If you've got some bash scripts and the likes of that, then port them to DCli, because then you're using Dart, a language you're more familiar with than you probably are with the likes of bash.
Awesome. Thank you so much. And yeah. So we're done. I'm done.
I appreciate the opportunity to come and have a chat to you, and I hope you find some use out of it.
Yeah, sure. Sure thing. Thanks.